Okay, so we're going to have a look at 2012, and it's the January C1 paper, and it's questions 1, 3a and 6. Question 1 is just straightforward differentiating that to give you 6x minus 4. Part 2, equation of a normal. So write out your formula as you usually do. You're lucky here because I told you the x and the y. So put the y in and then put the x in. Go over to the side to do the gradient. The gradient's when you differentiate, which is up there, 6x minus 4. You're told that x is 2. So the gradient is 6 times 2 take away 4, which is 8. Plugging it in over here, so it's minus 1 over 8, x minus 2. Times everything by 8, 8y minus 40 equals minus 1, x minus 2. Times out that wee bracket, so minus x add 2, everything onto one side. So it's x add 8y minus 40, take away 2 is minus 42 equals 0. Question 3a. If you fix this first, bring your x up as a minus 1, write your root x as x to the half, and that one's fine as x to the 3. And if you differentiate that, power goes to front, take 1 off. Power goes to front, 2 times the half is 1, take 1 off, 3x squared. You can leave it like that, or you can tidy it up if you want. So minus 3 over x squared, minus 1 over root x, plus 3x squared. And the last one, 6.1. The volume is the area. The area is a semicircle. A circle is pi r squared, times it by a half to get a semicircle, and times it by the length. You're told the volume is 125. Now, you can take a pi off each side and bring your 2 across to multiply. So 250 is r squared L. It wants it in terms of L, so bring your r squared across and divide. So L is 250 over r squared. Part 2 is wanting the surface area. So it's the roof plus the 2 ends. Now, the roof is the circumference times the length. And each end of 2 of them is a semicircle. So it's a half pi r squared. The circumference, you've only got half the circumference. So it's half pi d for circumference times your length. 2 times a half is 1, so it's just pi r squared. Diameter is 2 radius times L times pi r squared. Half times 2 cancels off, so you get pi r L plus pi r squared. You know your L from up here, so it's pi r 250 over r squared plus pi r squared. That cancels to give you 250 pi. R over r squared is an r on the bottom. Part 3. You're going to differentiate it because you want the max min. So ds by dr equaling 0. First of all, we've got to do ds by dr. I can't differentiate that at the minute because r is not on the top. So 250 pi r to the minus 1 plus pi r squared. Now I can differentiate it. Power goes to front, take 1 off. Power goes to front, take 1 off. You want that to equal 0. So I'm just going to tidy it up at the same time. Minus 250 pi over r squared plus 2 pi r equals 0. Bring this over to the other side. So you have 2 pi r equals 250 pi over r squared. Pi on each side can knock off. R squared comes up to r to give you r cubed. 250 divided by 2 is 125. Giving you r to be 5. Don't forget to find the second derivative. There's my first derivative, so just differentiate it again to get the second derivative. So that comes forward to give you 500 pi r to the minus 3 plus differentiating that gives you 2 pi. That tidies up to 500 pi over r cubed plus 2 pi. You know that r is 5. So your second derivative is 500 pi over 5 cubed, which is 125. That is a positive number, so it's a minimum. Now the question wanted you to find the surface area. So surface area, you just follow here as the surface area. It's 250 pi over r plus pi times r squared, which is 25. So 250 divided by 5, add your 25, gives you 75 pi.